Welcome to question 3 of the Year 10 end of year exam. It's about electrolysis. Everyone's heart sinks. A student makes an hypothesis. When different salt solutions are electrolyzed with inert electrodes, the product at the negative electrode is always a metal. Describe how you would test this hypothesis in the laboratory. You should draw a labeled diagram of the apparatus, give the independent variable, describe what you would see at the negative electrode if the hypothesis is true. Right, so that's our question. It's 5 marks, big marks available here. So you did this experiment and this is the diagram we're looking for. We're looking for it drawn with a ruler and we're looking for the surface of the electrolyte to be flat like that, not with waves on it. It needs to be a labelled diagram, so now I need to add some labels. The first label I need to add is we did it in a beaker. What we're electrolysing, the salt solution, you could either put salt solution or you could put the electrolyte. These are the electrodes and this is the easiest thing to call it would be a cell, but if you want to put a power supply you've got to specify that it's a DC, direct current power supply. Right, you could label the wires if you want, but there were no marks for it. This is what's needed. Right, so the experiment says when different salt solutions are electrolyzed with inert electrodes, the product of the negative electrode is always a metal. And now we need to talk about variables. Now we remember SID, SAM, we know control, the independent variable and the dependent. Yeah, I can spell. SID, SAM. Control, keep the same. Independent, we alter, which means change. Dependent, we measure or observe. Right, so what are we changing here? It says when different salt solutions are electrolyzed with inert electrodes, the product of the negative electrode is always a metal. So we're saying that whatever salt solution we use, we're always going to get a metal at the negative electrode. So what are we changing? What are we altering? What's the independent variable? The independent variable, well, we're changing the different salt solution, taking any salt solution we can think of, and we are changing it into there, putting it in as the electrolyte, doing the experiment and seeing what we get at the negative electrode. So our independent variable are the different salt solutions. Observation. Describe what you would see at the negative electrode if the hypothesis is true. Well, this is kind of saying what's the dependent variable, what's the measurement we're making, what's the observation we're making. And we're observing what the product is at the negative electrode, i.e., is it always a metal? If it's always a metal, we've proved our hypothesis true. If you're really smart, you could put positive and negative there on the electrodes. Just thought of that. Question 3. The student's hypothesis, as we know, is only partially correct. Explain why the product of the negative electrode is not always a metal. So the important thing to remember is we're talking about electrolyzing an aqueous solution of salts. So this is not a melts electrolysis. So we know as soon as it's electrolysis of solutions, we've got to remember our rules for the negative electrode. And the rule at the negative electrode is you will get a metal if the metal is below hydrogen in the reactivity series. If the metal is above hydrogen in the reactivity series, you'll get hydrogen instead. So the student here said you will always get a metal. So she was using salt solutions with the metal that was always below hydrogen in the reactivity series. However, if you used, we know that sometimes we're going to get hydrogen. So explain why the product of the negative electrode is not always a metal. Well, because sometimes hydrogen is produced. Why is that? We're going to simply state our rule. If the metal is higher than hydrogen in the reactivity series, then a hydrogen gas is evolved at the negative electrode. Okay, that's the rule. That's all they're asking for. They're asking for you to state the rule. And the rule is if the metal is higher than hydrogen, and if you use a comparative, you've got to say higher than what, bigger than what, blah, blah, blah. So higher than H in the reactivity series, hydrogen gas is evolved at the negative electrode. Question 3.3, the hardest bit. Predict the product at the positive electrode in the electrolysis of sodium chloride and copper sulfate. So now it's examining your understanding of the rule for the positive electrode for electrolysis of aqueous solutions. And the rule at the positive electrode is if it's a halide, if there's a halide present, I will get a halogen. If it's anything else, the hydroxide ion will react to give oxygen and water. So the halides are fluorine, fluoride, chloride, bromide, or iodide. Anything else, it will be the hydroxide ion that reacts to make oxygen and water. So let's look at our first one. Sodium chloride. Do we have a halide? Yes, we do. We've got chloride. So chloride is going to make the halogen, which is chlorine. The element's name is chlorine. When it's an ion, when it's gained electrons, it's a halide. Copper sulfate solution. Let's look at what we've got there. For the negative ion, it's a sulfate. Is that F minus, Cl minus, Br minus, I minus? No, it's not. So it's going to be the hydroxide ion reacts to make oxygen and water. So oxygen and water. That's the end of the question.